Hello learners, welcome to this education online program. I am teacher Akena Patrick Omoñ. I'll be taking you physics. This is lesson 1 for learners in senior 4. So our subject is physics. We shall be learning physics and our topic is circular motion. Circular motion. Now to begin with, motion generally refers to the change of position with time. Motion refers to change of position with time. So if a body moves from one point to another, we say motion has occurred. Then motion is grouped into two. Motion is grouped into two. One, we have the linear motion, and two, we have the circular motion. We have the circular motion. Now, what do we understand by the term linear motion? Linear motion refers to the motion of a body in a straight line. Straight line, that is when a body moves from one point to another along a straight line. For example, if a body moves from point A to another point B, so this motion is in a straight line. That's why we call it linear motion. The word linear comes from an English word line. Then our main concern for today is not going to be on the linear motion. We shall be learning about the circular motion. We have circular motion. Now, what do we understand by the term circular motion? We say circular motion refers to the motion of a body in a circular path, or we say it is the movement of a body round a circular path. Movement of a body round a circular path. Meaning when a body moves in form of a circle, when it starts from one point to another in form of a circle, so that motion we call it a circular motion. So to understand this, to understand circular motion, consider this illustration. To understand circular motion, let's consider this illustration. When the body moves in a circular path, let's assume it starts from point A. Then it moves along the circular path to another point B. So this body moves round a fixed point, and this fixed point is at the center of the circular path. Then this point that is found at the center of the circular path, we call it the center of the circle. This is the center of the circle. So now we have a line that joins the center of the circle to any other point along the circular path, and this line is called the radius of the circle, and we denote it with letter R. Then as a body moves from point A to point B, it is this same radius that will move also from point A to point B. So which means this distance from the center to another point on the particle is also called the radius of the circle. Then the center of the circle, we can denote it with letter O to mean the origin or the center of the circle. Then as the body moves from point A to point B, you find that the radius sweeps through some angle. Then this angle, we can call it theta. Then the distance that the body will cover along the circular path, say from point A to point B, we call it the arc length. And this arc length, we can represent it with letter S. So this is what we mean by a circular motion, just a motion in form of a circle. So the change of position in this case is along the circular path. Now let's look at some of the examples of circular motion that we have. Examples of circular motion. That is the examples of bodies that move in a circular path. Now, what are these examples that we have? One, we have the motion of electrons round the nucleus. The nucleus of an atom. So, in an atom, we have a central part that is called the nucleus. Inside the nucleus, we have subatomic particles. We have the protons that carry positive charge, then we have neutrons that are neutral in the nucleus of the atom. Then outside the nucleus, we have electrons that are orbiting around the nucleus, means they are moving around the nucleus. This is what I mean. If this is an atom, then at the center of the atom, we have protons that are positively charged. Then we have neutrons that are neutral. They carry no charge. Then outside the nucleus, we have electrons. So these electrons move around the nucleus. So this movement of the electrons around the nucleus is an example of a circular motion, or we say motion in form of a circle. Then the second example of a circular motion is the second hand of a watch with a circular dial. So now when we look at a watch has three hands. There's one hand that shows the minutes, we call it the minutes hand. Then there's one hand that shows the seconds, it's called the seconds hand. Then there's one hand that shows the hours, it's called the hours hand. So now when you look at all those three hands, they move in form of a circle. We say they move in a clockwise direction, means the circle is in a clockwise direction. So that is one of the example of circular motion. Then the next example of circular motion that we have is the motion of an artificial satellite. An artificial satellite moving around the earth. So when a satellite is projected to move around the earth, it is going to orbit the earth, means it is going to move in a circular form. So when it moves in a circular form, that is already a circular motion. Then the last example of circular motion that we have is the motion of a car. Motion of a car round a circular track. So when a car is moving, you find that at a certain point it will be negotiating a corner. So now when it is negotiating a corner, you find that in that case the car will be moving in a curved way. So that curve is also part of a circular path. So that is an example of circular motion. These are not the only examples. There are so many other examples of circular motion that we have. Now we have some of the key terms used when we are dealing with circular motion. Key terms used in circular motion. These key terms are very important. They will help us to understand what circular motion is. Now, to understand these key terms, we have to first keep in mind the nature of how a uniform circular motion looks like. One of the key terms that we shall start looking at is angular displacement. We represent it with theta, angular displacement. So now, looking at this circular path, when a body moves from point A to point B, you find that it is sweeps through some angle theta. So the angle that is swept through by the radius joining the particle to the center of the circle is what we call the angular displacement. So we say angular displacement refers to the angle swept through by the radius joining the particle to the center of the circle. So now the angle that is swept through by the radius, this is the radius that joins the particle to the center of the circle. So this angle that is swept through by this radius is what we call the angular displacement. So now angular displacement is measured in a unit called radians. It is measured in radians. Or simply in short we can write it as rad. So this is the SI unit of angular displacement. As we know in physics, it is always very important when you understand a term, you need to know its unit, since it will always be as define angular displacement and state its unit. So you define the angular displacement refers to the angle swept through by the radius joining the particle to the center of the circle. And you say it is measured in a unit called radians. Or when you write it in short as rad, it is also okay. So now after understanding this first term, now what do we mean by radians? So radians become our second term that we have to look at when dealing with circular motion. Radians. So radians is our second term. Now what do we understand by the term radians? Radians means there are many. If it is one, we say a radian. So now what is a radian? We say a radian is the angle subtended at the center of the circle when the arc length is equal to the radius of the circle. So the angle subtended at the center of the circle, when the arc length is equal to the radius of the circle, So what we mean is this angle that is subtended at the center of the circle when the arc length is equals to the radius of the circle. Here we mean if the arc length, that is the distance between 2 points along the circular path, becomes equals to the radius of the circle, then this angle that is swept through is what we call a radian. Now, for example, if the arc length, okay, if arc length, if the arc length is equal to, let us say, 3 centimeters, and the radius r is also 3 centimeters, we can see the arc length is equals to the radius of the circle, meaning the distance along the circular path is equal to the distance between the particle and the center of the circle. Then the angle that is swept through becomes a radian, or we say it is 1 rad. A radian. Or if you don't want to say a radian, you say 1 rad. So that is what we mean by radian. Then we have other terms that are still used when we are dealing with circular motion. So now, before we go to the next term, the angle that is swept through, we call it theta, and it is also called the angular displacement. Then when the angle, when the arc length becomes equal to the radius of the circle, we call it 1 rad, or we say it is a radian. So we have to know that. But what is 1 rad? How do we get 1 rad? We say 1 rad can be got by 2 pi divided by 360 degrees. 1 rad is equal to 2 pi divided by 360 degrees. Sorry. Now, when a body completes a full circle, means it has moved in a full circular path. Then the total angle in a circle is 360 degrees. But how do we write 360 degrees in radian? We say at the center of the circle, at the center of the circle, meaning when the body has moved in a full circular path, we shall have that 2 pi rad is equal to 360 degrees. Just as we know from mathematics, we say the total angle in a circular path is 360 degrees. So we shall find that this 360 degrees in radian, it is equal to 2 pi rad. So now how do we get 1 rad from here? So we say from 2 pi rad, which is equal to 360 degrees. So we can get 1 rad from here. How do we get 1 rad? We divide both sides by 2 pi. When you divide this side by 2 pi, you find that 2 pi divided by 2 pi, it goes 1. So you're going to have 1 rad, which is equal to 2 pi 1 by 2 pi, it goes 1. So you are left with 1 rad. 1 rad is equal to 360 degrees divided by 2 pi. But we can see that 360 degrees can still be reduced by 2. So let's go ahead and reduce it. Now when we divide 360 degrees by 2, so we have 1 rad is equal to 360 degrees divided by 2 pi. You find by 2 it goes 180 degrees. Then 2 into 2 it goes 1. So you have 1 rad is equal to 180 degrees divided by pi. So now in mathematics, but we take pi to be equals to 3.14, that is to 2 decimal places. So now where there is pi, we are going to substitute this value, which is 3.14. So you say 1 rad is equal to 180 degrees divided by 3.14. So this one will give us 1 rad is equal to, now when we divide 180 degrees by 3.14, we get 5.73. That is to 2 decimal places. Sorry. We're going to get 57.3. That is to 1 decimal place. So which means the value of 1 rad is equal to 5.73 degrees. Sorry, 57.3 degrees. Now, how do we get the arc length? That is the distance moved along the circular path. That is when a body moves from one point to another along the circular path. So when a body moves from point A to point B, how do we get this distance, which is called the arc length? If a body moves from A to B, then we have the arc length. That we said we can also represent it with letter S. Is given by r theta, where r is the radius of the circle and theta is the angular displacement. So you can be asked, determine the arc length for a body moving along a circular path of radius 4 meters with an angular displacement of 10 rad. So from here you can be able to find the arc length using this formula. So now let's look at one example of how we can apply this formula, or how we can get the arc length for a body moving along a circular path, say from point A to point B. We have example 1. Example 1, which says the radius of a circle is 6 meters. The radius of a circle is 6 meters. Then if calculate the length of the arc. Calculate the length of the arc. The length of the arc means the distance along the circular path. Calculate the length of the arc of the circle. If the angle subtended by the arc, if the angle subtended by the arc is 180 degrees. So this is how a question can come. The question says the radius of a circle is 6 meters. Calculate the length of the arc of the circle if the angle subtended by the arc is 180 degrees. So now how do we get the arc length? Just from the formula that we have given, we said arc length is given by radius times the angular displacement, and the angular displacement is the angle that is swept through. So now in our solution, we need to read through the question. We find out what is given in the question. So now when we read the question which says the radius of a circle is 6 meters, so we find that the radius is given. So say given r is equals to 6 meters. Then when we read further, calculate the length of the arc of the circle if the angle subtended by the arc is 180 degrees. And we said the angle that is subtended is called the angular displacement, and represent it with letter theta, which is 180 degrees. So now you are to determine the arc length. Now from the formula that is given, from arc length that we represent with letter S is equal to r theta, where r is the radius of the circle, then theta is the angular displacement. So in short, we can write S is equals to r theta. Now let's go ahead and substitute. We substitute what is given in the question in our equation so that we can get the arc length, that is the distance along the circular path. So S is equal to, r is given to be 6 meters. 6 meters times theta. Theta is the angular displacement, and angular displacement is measured in radian, and its value is 180 degrees. So now what do we get when we multiply 6 meters times 180 degrees? Now from our mathematics, when you multiply this S, you're going to get 8050. That is from mathematics. Learners can either use calculator, or if you are good in multiplication, you can do it that way. Sorry for this. So when you multiply with your calculator, you're going to get S is equals to 1080. Since S is the distance along a circular path, so the unit is going to be in meters. That is the distance along the circular path, or is called the arc length. So now let's look at another example. That is example 2. Example 2. Example 2 says the radius of a particle moving along a circular path. The radius of a particle moving along a circular path. Along a circular path moving along a circular path, sweeps through an angle, of 60 degrees. Sweeps through an angle of 60 degrees at the center of the circle. At the center of the circle. Full stop. Calculate the angular displacement of the particle in radian. Calculate the angular displacement of the particle in radian. So this is how a question may also appear. The radius of a particle moving along a circular path sweeps through an angle of 60 degrees at the center of the circle. You have to calculate the angular displacement of the particle. Just as I said, angular displacement is the angle that is swept through by the radius joining the particle to the center of the circle. Now let's look at our solution. Now when a question is given like this, it's always very important to read through and find out what is really given in the question. So we shall find out what is given in the question is the angle that is swept through. And that angle that is swept through, we call it theta, which is 60 degrees. 60 degrees. So now when you look at this question, this is only what is given in the question. So the angle that is swept through is called the angular displacement. But the question is again asking you to get the angular displacement, but in radian. Simply, in a simple term, they're asking us to convert these degrees to radian. They're asking us to convert degrees to radian. So now we say from 2 pi rad, which is also equal to 360 degrees. Now they want you to convert these degrees to radian. Now we have to first find out how many radians are there in 1 degree. How many radians are there in 1 degree? Which means from this relationship, we have to first find 1 degree. Now to find 1 degree, we are going to divide both sides by 360 degrees. So that we shall have only 1 degree equals to. So now we have 2 pi rad, which is equals to 360 degrees. But we want to get only 1 degree. To get 1 degree, we divide both sides by 360 degrees by 360 degrees. So by 360 it goes 1, by 360 it goes 1. So you have 2 pi rad divided by 360 degrees is equal to 1 degree. So now if we have this, only 1 degree is equal to 2 pi rad divided by 360 degrees. Now what about 60 degrees? Now I want to relate this in a simple term. If it is said 1 pen costs 5 South Sudanese pounds, then what is the cost of 4 pens? So you have 4 pens is equal to, you're going to multiply the number of pens times so you're going to multiply the amount times the number of pens, of which you will get 20 SSP, which means 4 pens cost 20 SSP. So it's the same idea that we are going to apply here. If 1 degree only is 2 pi rad divided by 360 degrees, then what about 60 degrees? Which means we are going to multiply the whole of this times 60 degrees. So now you're going to say 1 degree is equals to 2 pi rad divided by 360 degrees. We multiply the whole of it by 60 degrees. So now this one is divisible, can be divided. So 1 degree, okay. Now if 1 degree is the same as 2 pi rad divided by 360 degrees, then what about 6 degrees? 6 degrees, 60 degrees is equals to 2 pi rad divided by 360 degrees, the whole of it times 60 degrees. So you find that 60 can be divided into 360 degrees. So by 60 it goes 1. Then by 3, okay, by 60 into 360 it goes 60 degrees. So now you have 360 degrees. You have 360 degrees. 60 degrees is equals to 2 pi rad divided by 60 degrees. So 60 can still be reduced by 2. Find that by 2 it goes 1, by 2 it goes 30 degrees. So now 60 degrees is equals to pi rad divided by 30 degrees. But when you have to look at this, the degree and the degree will also cancel each other. So you will only be remaining with 30. Now 60 degrees is equals to, as we said, we take the value of pi, but pi is equals to 3.14. So now when we substitute where this pi, when we substitute 3.14, you're going to have 3.14 rad divided by 30. Now 60 degrees is equal to, now what do we get when you divide 3.14 by 30 degrees? Now from our mathematics, when you divide that, we are going to get 1.05. And since the question says you have to get the angular displacement in radian, so our unit is going to be rad. Just as I said, you can either write radians or you write rad. So from here you can conclude to say, therefore 60 degrees is equal to 1.05 rad. So this question simply is asking us to convert degrees to radians or to rad. So from the start of the lesson, we looked at the definition of circular motion. Then we also looked at the examples of circular motion. Then key terms used when dealing with circular motion. So up to this point, there are still other terms that we can use when we are dealing with the circular motion. So the next term that we shall go ahead and look at is called the angular velocity. Angular velocity is the next term, but due to time, we are going to stop here. Then in our next lesson, we shall continue with other terms. That is the angular velocity. We have the period and frequency. So thank you, our learners, for tuning to for being in this part of the lesson. I remain teacher Kiana Patrick Umoni. Thanks for listening.